Hi guys, now we are going to study about this module number 5, that is lubrication and bearings, where in this module particularly we are going to concentrate much on hydrodynamic lubrication and particularly journal bearings. Okay, generally you are heard of only ball bearings, but you are going to come up to some new type of a bearing that is called as a journal bearing. Before going into this chapter, we need to know one basic concept, that is wear. Okay, why exactly we need to study, I'm going to tell you. Now see, what do you mean by wear, or is it an advantage or disadvantage? Generally, particularly in our mechanical engineering field, um, wear is a component which has to be controlled. If that has not been controlled, it is going to have an impact on our machines. So how, what do you mean by wear? Means it's nothing but wear is a phenomena where the surface will be eroded with due to the friction. Now, how exactly it is going to happen? Let me explain here. See, if you look at the here, I have written there is a two components which are in contact with which are in contact with each other. Now, when I try to pull them, okay, when I try to pull them, what is going to happen here is, since their surfaces are in contact with each other, friction comes in picture, which leads to the worn out of a surface. Now, how exactly the wear is happening? If you want to understand that, first, okay, we need to look at the surfaces at a microscopic level. Say, for example, if I try to focus that surface in a microscope, you're going to get an improper surface or an irregular surfaces like this. See, the peaks of these irregular surfaces, we generally call it as asperities. Now, generally, whenever a wear is going to happen, the wear will leads to flow lines or wear debris. What do you mean by flow lines? Means I'll show you an image for you. See, in this shaft, okay, you can see this, the lines, what are you seeing on the shaft, okay, that are called as flow lines. Now, how exactly this will be formed, I need to explain you. Okay, now see, um, when both the surfaces are brought in contact, okay, see, this is being shown here. Okay, see, when both the surfaces are brought in contact with each other, say for example, the surface one or the green color surface is very hard. Now what is going to happen is, whenever the hard material is there, that hard material will penetrate into the surface of the soft material. Okay, now once the asperities has been penetrated into the surface, and as you try to rotate or as you try to move the hard surface over the smooth surface, you can see the flow lines will be formed on it. Okay, sometimes what happens is, these asperities of the hard material or the soft materials will be, okay, welded. Okay, when it has been welded, okay, then when you try to pull them, the asperities of the weaker member will be broken out, which may lead to the wear debris, so which will be in a small powder form. Okay, so by thereby wear is going to cause flow lines as well as wear debris, okay, on your material. See, whenever the wear debris is present in between these two surfaces, which also increases the wear rate. Now, what you can do is, you can never, only thing is, you can never avoid the wear. You need to reduce the effect of this wear. Okay, so how are you going to avoid, or how are you going to reduce the effect of wear? This wear means by lubrication. See, here the surfaces, when surfaces brought in contact, the wear is going to come into picture. If the surfaces are never brought in contact with each other, then we can avoid this. Okay, now there are different types of lubrication. Okay, so that is a concept we are going to understand now. Lubrication is a process, okay, where you can avoid the wear between the surfaces which are in relative motion. There are different types of lubrication. You can see one of them is thick film lubrication, thin film lubrication, and boundary lubrication. What do you mean by thick film? Is here both the surfaces are separated by a thick film. Okay, thin film means here both the surfaces are separated by thin film, and here you need to understand, in a thick film lubrication there is no surface to surface contact. Also in your thin film lubrication there will be no surface to surface contact will be there. But the boundary lubrication is a type of lubrication where both the surfaces are separated by a small film. Okay, but Here, whenever there is a relative motion, there will be a surface to surface contact. Particularly at the asperities, there will be contact with both the surfaces. Okay, these are the different types of lubrication which are available. Okay, now whenever you are going with the lubrication, there are certain properties that the lubricant should satisfy. One of them are viscosity. Generally, if you are using a lubricant between in order to separate two surfaces, it should have high viscosity. Okay, so that it can withstand, okay, that heat or that load and other things. And moreover, it should have high flash point and high fire point. See, I'm talking about this high flash point and high fire point because certain times what is going to happen is due to the friction between the components, the temperatures will be increased at a higher rates. At that point of time, if the oil is going to have a low flash point and fire point, it is automatically going to catch the fire, and which is not going to serve my purpose. So we need to ensure that whatever the lubricant you are using in order to separate, okay, in order to reduce the wear, you ensure that the flash point and fire point of that, okay, particular lubricant should be very 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 high. Okay, and oiliness, see, this is a kind of a property where it refers to the surface tension and slipperiness. Okay, it should be able to maintain a film between the rubbing surfaces, so that is called as oiliness. The main purpose of lubrication is to reduce the friction. See, when you are reducing the friction means obviously you are reducing the wear. Okay, not only reducing the friction, not only reducing the wear, sometimes lubrication also uh, it should carry away the heat which is being generated within the component. Okay, and also see, whenever there is a reduction in wear, automatically the vibration and other things will be automatically reduced. So these are the major purpose of lubrication. Okay, so there are different types of lubricants also. See, I need to tell about this. There are different types of lubricants, as we all know that. Okay, there are solid lubricants, semi-solid lubricants like grease, okay, and liquid. These, there are three types of, okay, solid, semi-solid, and liquid. So we know that all the mineral oils, okay, all the mineral oils are some example of liquid. Semi-solid, you grease, okay, grease is one example of a semi-solid. And for a solid lubricant, just like solid lubricants can also graphite is one of the example. Okay, graphite is one of the example for a solid lubricant. Okay, so these are the different types of lubricants which are available. Based on the suitability, you need to pick the lubricant. Okay, next we are going to study about the bearing. What do you mean by a bearing? Means a bearing is a mechanical component, okay, which provides a relative motion, or which transfers the rotary motion, okay, from rotary motion without a. So next we are going to learn about bearings. See, generally a bearing is a machine member which supports and guides and restrain moving elements, particularly shafts. Okay, there are different types of bearings. Among that, sliding bearings and rolling bearings. You are very much aware of this. Rolling bearings. Okay, ball bearings and roller bearings are some of the example of this, but we are not going to discuss much about this. So among sliding, we have different types of bearings. Well, full journal bearing, partial journal bearing, okay, thrust bearings, slider bearings, and hydrostatic bearings. Among that, we are going to study full journal bearings and your partial journal bearings, particularly in this module. Okay, but you also need to understand on what principle these journal bearings are going to work. And journal bearings somewhat just look like this. Okay, this is a journal bearing which has been used in your steam turbines. Okay, though it's just like, it's going to look like a washer which is going to cover your shaft. Yes, these are some of the examples of your journal bearing. See, this is one type of a journal bearing. Okay, particularly this type of bearings is used in turbochargers. Okay, this is used in your steam turbines. You can see the wear which is happening at the shaft and between the shaft and the journal. Okay, this is one image. Okay, see, this is a example. This is a turbocharger. Okay, which is used generally in diesel engines. Okay, to charge the air. Okay, here you can see the two journal bearings which are mounted. Okay, a shaft is mounted over the bearings. Okay, now if you just have a look at this bearings, what you can see here is you can see the holes which are provided along the radial direction of your bearing. Okay, see, these holes allow the oil to enter and allow the oil to exit. Okay, now look at this. We are going to this is a journal bearing. This is a full journal bearing. What do you mean by partial bearing? Means, okay, see, in this hole a shaft will be, okay, this hole is allowed for shaft, and these small holes you can see the entry and exit of the oils. Okay, partial journal bearing is a bearing which covers a partial portion of a surface. This is a full journal bearing where your shaft will be covered fully. Okay, that is why this is called as full journal bearing. If your shaft is covered, only a portion of a shaft is covered, means then we generally call it as partial journal bearing. See, this journal bearing is going to work on the concept of hydrodynamic lubrication. What do you mean by that hydrodynamic lubrication? I'm going to explain you now. Okay. First, what you need to understand here is, see, here I have written, okay, here you can see a circle which is written in a green color. It's a journal or a shaft. Okay, and a circle in a blue color is nothing but a bearing surface, and there are oil holes which allow the oil to enter into the gap which has been provided here. See, generally the gap between the shaft and the bearing will be very less, which will be the order of 10 to the power minus 3 meters. Okay, but in order to understand the concept, I have been exaggerated the diagram. Now see, once the oil is allowed to fill in the space, it will be somewhat like this. Now what is going to happen is, I'm going to switch on the journal, or I'm going to start rotating this shaft in a clockwise direction. Now what is going to happen is, as I start to rotate this one, in a clockwise direction, okay, when I start to rotate this one, this is going to slide over the bearing surface. Okay, see, when your shaft is going to rotate, what is going to happen is, whatever the fluid particles which have been adhered to this, okay, which have been adhered or which have been sticking to this shaft, also starts rotating. Okay, now look at this. Like this, you can see the fluid particles. Now what is going to happen is, this fluid particles is also going to start to rotate with your shaft. Now the fluid particle which is next to it also starts to rotate with alongside the shaft. Now what is going to happen is, as the fluid particles start to rotate with the shaft, as it is going to rotate, and all the fluid particles also will be brought and left over here. Now a pressure will be built at this point. Okay, because here all the fluid particles has brought, and there is no space for the fluid particles to move on to the other side. Now the pressure will be built at this region. Okay, now here the pressure will be less, because here the high pressure zone has been created, here the low pressure zone will be created. Now there is a pressure difference. Now what is going to happen is, this fluid particles lifts the journal and move to the other side. Thereby a convergent and divergent section will be formed. Okay, now once the enough pressure is built at this location, automatically it is going to lift your journal and it is going to move on to the other side. Like this, you can see a gap between the journal and the bearing surface can be achieved. Now whenever there is no contact, automatically there is no point of wear. Okay, so thereby we are going to achieve okay, lubrication between the journal and the bearing. So this is called as hydrodynamic lubrication, where a fluid film pressure is generated only by the rotation of the journal. Okay, so this generally, see, you are going to see this is a convergent zone, converging zone, where the pressure will be very high. This is a divergent section where the pressure will be low. Okay, pressure will be low, pressure will be high. So this is, pressure will be high. Here I'm not providing any of the aid to separate the journal and the bearing surface. Here what you need to do is you need to ensure that there is a continuous supply of oil between the journal and the bearing. If oil is continuously supplied, okay, the speed of the journal will take care of this gap. Okay, so what you need to have in your hydrodynamic bearing is that you need to ensure the continuous supply of oil, so thereby you can achieve the lubrication between the journal and the bearing, okay, without any extra cost, without any extra machinery. So you can achieve this. So this is how a hydrodynamic lubrication is going to work. Okay, so what is going to happen in your hydrostatic bearing means, hydrostatic bearings, okay, see, this is a bearing and this is a journal. You are going to provide, you're going to pump the oil continuously such a way that, okay, you're going to pump the oil continuously so that the gap between the journal and the bearing is maintained. Here you need the pumping equipment, okay, you need to pump the oil in your hydrostatic bearing. Okay, for that you need to have a pump and you need to have a separate mechanism for pumping the oil, whereas for your hydrodynamic, no pump and no any extra devices is essential. Okay, it is, if the oil is continuously available, it is going to build the thick film of oil between the journal and the bearing. Now how are you going to achieve this? First, it is going to take some time for building this thick oil film. See, initially, okay, a boundary lubrication, and later as the speed of the journal is increased, we can achieve the thick film lubrication. Okay, the friction will be reduced with the increase in speed. Okay, here initially you are going to see the boundary lubrication. Okay, initially you want to see, initially the friction will be very high. As, look at this diagram, as I switch on the shaft, or if I start to rotate my shaft, okay, here surface to surface contact between the journal and the bearing is there. So at that point the friction will be very high. So that friction is shown here. Okay, or in other words, coefficient of friction will be very high. As it starts to slide over the surface, a boundary lubrication will be formed. Later, with the increase in speed, that is what this, with the increase in speed, what is going to happen? More and more fluid particles will be coming here and will be mounted over here, which is going to increase the pressure. Okay, so this thing is explained with the help of this diagram. See, initially the coefficient of friction is more. As your shaft is going to rotate, okay, a boundary lubrication will be formed, and later which will be converted into a thick film lubrication. A thick film will be created between, okay, between the journal and the bearing. Okay, this is how we are going to achieve the hydrodynamic lubrication between the journal, in a journal bearing. Okay, now we need to know certain technical terminologies in this module. What are those means? Certain basic definitions like